Good day everyone, I am Gerald Villa, BCMA3A, and for this video I'll going to discuss the manometer pressure problem, measuring the gas pressure and the atmospheric pressure. So how would you answer this question? If the atmospheric pressure is 760 millimeter of mercury, what is the pressure of the gas in manometer? If the mercury column is 60 millimeter higher on the atmospheric side, so we're gonna draw this one. We'll try to find out. Please be considerate in my drawing. This side is the gas pressure, and this side is the atmospheric pressure, and this side is open to the atmosphere. And when we're gonna have mercury inside the container, then this one, we're gonna shade this one for more clarification para maklaro gamay. So since as the given to the problem that the atmospheric pressure, the 8m is 60 millimeter higher than the gas pressure. So this one. So I'm gonna put this 60 millimeter of mercury. So the 60 millimeter of mercury is their height difference. The height difference between the atmospheric pressure and the gas pressure. So what is the pressure of the gas in nanometer based on this picture? Now keep in mind that the value of the atmospheric pressure is 760 millimeter of mercury. So all we have to do to calculate the gas pressure is you either add or subtract 60 millimeter of mercury from the value of the atmospheric pressure, which is the 760 millimeter of mercury. So the answer is possibly the answer is either 760 millimeter of hydrogen plus the height difference, which is the 60 millimeter of mercury, or the value of the atmospheric pressure 600 millimeter minus 60 millimeter of mercury. So as of now, we gonna point that one later. So what we need to determine conceptually is this pressure greater or less than the atmospheric pressure? We can tell based on the height of the column. the pressure equals the force per unit area. So the atmospheric pressure is a certain force of the surface of that fluid. The gas also exerts pressure in the fluid as well. So what's stronger? So the gas pressure is pushing down this on the fluid, on the mercury fluid, and the atmospheric pressure is also pushing down. So which one is pushing down more in the fluid? And you can tell based on the level of the fluid. Now let's say if the mercury was the same height, if it has the same height, they both exert equal force on the mercury column, as if they had the same height. So the both exert equal force to the mercury column. Now let's see if the height is different, and I'll give you two scenarios. And I'll make two scenarios. This one is the gas pressure, and this is the atmospheric pressure. So as we see at the drawing, the gas on the left side exerts more pressure than the gas on the right side. Why? Because it pushing down on the mercury column more than the right side. This is the mercury column. Mercury. Wait. Oh. So therefore, the pressure is going to be higher on the left side than the right side. So the pressure in this side is more higher than this one, because as you see, this is a little bit lower than the right side, the atmospheric pressure side. So at the next scenario, this is the left side is the gas, and the right side is the atmospheric pressure. So in this side, in this drawing, the right side pushes more than the left side, as you see it to the drawing, because this fluid is pushing down more than the left side. This is the left side and this is the right side. So this pressure is gonna be higher. The pressure in this side, which is the atmospheric pressure, is a little bit higher than the pressure on the gas side, which is in the left side. So now, example, this level on the left, the level on the left is a little bit lower than the right, like this one, left, lower than the right. So therefore, in this case, the left side is more stronger than the right side. So we're gonna neglect that because this is the true illustration and this is the true representation. So to calculate the gas pressure, and it's gonna be greater than 760, so we're gonna add 60 to 760. So since the gas pressure is greater than the atmospheric pressure, so we gonna add 60 millimeter of mercury to the value of the atmospheric which is 760 millimeter of mercury. So the equation goes like this: 760 millimeter equals 820 millimeter of mercury. So why we add 60 millimeter of hydrogen then subtract it? Because if the gas pressure is lower than the atmospheric pressure, then we gonna subtract 60 millimeter of mercury to the equivalent value of the atmospheric pressure, which is 760 millimeter of mercury. So because the result that we get to the problem, to the solution, was that the gas pressure is greater than the atmospheric pressure. So that's why we're gonna use this equation, and this is the answer. So thank you and God bless.